Hello viewers, welcome back to my YouTube channel. I am Tutor Dozy and this is Dozy Tutorial. If this is your first time watching my video, please kindly rush now to the notification button, subscribe and share with your friends. Alright, today in this video we are going to discuss dimension analysis. Dimension analysis. Now, have you asked yourself how physicists get to know the correctness of a formula or an equation? Yes, it is through dimension analysis. All the quantities that are under physics, their formulas, their units, and how they are related with other formulas. All these ideas are through what? Dimension analysis. Alright. Now, for you to understand dimension analysis very well, you need to understand the basic quantities, that's the fundamental quantities and the derived quantities. Okay, first, we have what we call physical quantities. Physical quantities. What are physical quantities? Physical quantities are quantities that can be measured. Physical quantities are quantities that can be measured. A quantity is anything that can be measured. Now, the physical quantities are quantities that can be measured. Now, under the physical quantities, they are subdivided into two, where we have the fundamental quantities and the derived quantities. In total, we have the fundamental quantities and the derived quantities. Another word for the fundamental quantities are what? The basic quantities. Alright, now what about units? Unit is the standard of measuring a quantity. Unit is a standard of measuring a quantity. Most of the quantities in physics, they have their own unit. Under the unit, we have the CGS unit, that is the centimeter, gram and second system. And we also have the KMS unit, that's the kilogram, the meter and the second system. So this, the KMS, or you can call it the MKS, is the System International Unit. It is the one used globally. The SI unit as the System International Unit. The MKS, where this represents meter, this one represents kilogram, and here we have seconds. Alright, now what about dimension? Okay, dimension is the relationship between a quantity and the basic quantities. The relationship between a quantity and a basic quantities. Now remember, there are some quantities that are dimensionless. What do you mean by this? They don't have units. Why are they dimensionless? It is as a result of a ratio in which their numerator and their denominator has the same unit, or they are similar. So because of that, they now become dimensionless. We have the examples here. We have the tensile strain. Remember, strain is equal to extension over length. Extension is measured in meter, length is also measured in meter. So meter will now cancel meter. It will now become dimensionless. We have angles. Pi, they are dimensionless, and so on. Alright, now let's quickly move on to our dimension analysis, as we have explained the introduction part of it. But here we need to have the idea of fundamental or basic quantity and the derived quantity, because it's very, very important. If you find this video engaging and if you gain value, please do well to subscribe, like and comment. Alright, now here the fundamental or the basic quantities are quantities that are independent. They are quantities that are independent, and they cannot be expressed or defined in terms of other quantities. I said fundamental or basic quantities are quantities that are independent and cannot be expressed or defined in terms of other quantities. What are the examples of fundamental or basic quantities? Okay, now let's put them down. We have the length, we have mass, we have our temperature, we have time, we have amount of substance, we have light intensity, and we have electric current. These are the fundamental or the basic quantities. Let's go to their unit. Length, the SI unit is what? Meter. For mass, we have kilogram. For temperature, it is what? Kelvin. That's absolute temperature, Kelvin. Time is in seconds. Amount of substance is in mole. Light intensity, candela, CA, candela. Now, electric current, that's ampere. Sometimes. So these are the fundamental or the basic quantities. Now, what about derived quantities? Derived quantities are those quantities that depends on the fundamental quantities. They depend on the fundamental, and they can be expressed and defined in terms of other quantities. So they depend on fundamental quantities and they are gotten from them. Alright, the examples here, we have area, we have volume, we have the speed, the velocity, we have the acceleration, we have force, we have work done, we have energy, we have power, and so on. So these are examples of derived quantities. Now remember, these 7 quantities here are fundamental. Other quantities are what? Derived. They are gotten from the combination of 1 or 2 quantities from here. Do you understand? Okay. Alright. Now let's dive into the analysis of the derived quantities. Since we have gotten the fundamental quantities and see that they are independent, so we can't get any of these quantities from combination. They are basic. So let's focus our interest on the derived quantities and get their dimensions. Now let's find the dimension of some derived quantities and their basic units together with their SI unit. Now the first one, we have area. Remember, area is what? Length times breadth. Now, the dimension for length and breadth are what? It's very, very important to know this. Now, remember, distance, length, breadth, width, height, all of them are the same. They have the same dimension. What is the reason for that? Yes, because they are simply gap between points. Gap between points. Now, if you start from here and move to here, here can be your point A, and this your new position where you stopped is your point B. Now the gap between them is called distance. You can also regard them as length, width. Down to my up is what? My height. So if you measure it, you see that this is point A and here is point B. So the gap between them is just height. So all of them are what? Are the same with what? Length. They have the same dimension, including displacement. Alright, so because of that, we are going to use gap, L dimension. YM is for mass, L stands for length, and T stands for time. These are the basic dimensions used under mechanics. Alright, the L times Our brief is L again. Now we have N squared. So now length is measured in meter, right? Meter, so we have meter squared. And the SI unit for area is also meter squared. Now for volume we have length times breadth times height. Our length is n times breadth is also n, and our height is also n because they have the same dimension. I've explained it earlier. Equal to n times n times n give you n cubed. And this is the unit, the basic unit, and this is the SI unit. Alright, the next one we have is what? Speed. Speed is defined as what? Distance over time. That's for speed. Distance over time. Okay, our distance is length and our time is what? T, right? So this gives us LT minus 1. When this T, according to the law of indices, that's under indices, when this T comes up, it bears a negative power. When the T, which is the denominator, comes up, it becomes minus. Yes, so here we have our N to be meter and our T to be seconds, so meter per second, and this is also the SI unit. Now the next one, we have velocity. Here we have velocity. Velocity, we have displacement over time. So for our displacement we have length and our time we have t, which is same with speed. Now the dimension for speed and the velocity are the same. What is the subtle difference there? Because speed is a scalar and the velocity is a vector. That's the difference between them, but their dimensions are the same. Next one we have acceleration. Acceleration is equals velocity over what? Time. This is the formula for acceleration. Now we have gotten our velocity to be n over t, right? So we have n over t divided by t, and this equals n over t times, according to board maths, you have to turn it upside down. We have 1 over t, which is n over t times t is t squared, which is n. Once the t comes up, it becomes t minus 2. So we have n for meter and t for what? Seconds raised to power minus 2. This is the same as the SI unit for acceleration. Alright, the next one we have here is force. Force equals mass times what? Acceleration. What is the dimension for mass? We have m, right? Good. Then we have times. This is our acceleration, m over t squared. So putting them up together, we have m, and once this comes up, it becomes t minus 2. Now this is the dimension for force. Our m is our mass measured in what? Kilogram, and our length is what? Meter, and our time per second squared. This is the basic unit for force, but this is not the SI unit for force. The unit for force is what? Newton. Because the person that discovered the laws of force is what? Isaac Newton. So from now use Newton as the system international unit for force. Now the next one we have here is what? We have work done. What equals to force times displacement. Now our force is what? M L over T squared times displacement is M, which is, combining them, we have N times L squared, then this T, bringing it up, it becomes T minus 2. So here we have kilogram meter square per second squared. But the SI unit for work done is what? Joules. So these are the examples from what we have discussed so far. These are their dimensions. Alright, let's look at the solved problems here. One, we have which of the following units is equivalent to kilogram meter per second? Which of the following units is equivalent to kilogram meter per second? From the options given to us, we have our A, Newton per second. We have B, Newton meter second. We have C, Newton seconds. Then we have D, Joule per second. Alright, they just want us to what? To get the unit that is equivalent to this. That's what we are asked to calculate for. Alright, we are going to solve for their dimensions to know if it's going to correspond with the units that we have here. Breaking them down one after the other to know if you're going to get this. Alright, let's solve. So here we have Newton is m and t minus 2 times seconds is time t minus 1. Applying the law of indices here, we have m and t. Because the base are the same, we now have to add up the power. So we have minus 2 minus 1. This gives us m and t. Minus 2 minus 1 is minus 3. For this one, we have m and t minus 2 for our Newton, which is force. And m is what? Meter, which is length. S, seconds, which is what? Time. So now, combining them, we have m times n squared. This and this, applying the law of indices, we have minus 2 plus 1. So here we have m squared t minus 1. Alright, now for this one, we have m t minus 2 and what? T. Because this s represents what? Time. Now we have, it has invisible power, which is what? 1. Using indices, now we have m t minus 2 plus 1, which will give us m t minus 1. Then for this one, we have Joule. Joule is what? Joule is work done, right? And we have work done to be m squared t minus 2, right? Then times our seconds is t times t minus 1. Applying the law of indices, we have m 2 t minus 2 minus 1. This gives us m squared t minus 3. Okay, now let's go back and get their unit. This is kilogram meter seconds cube. The seconds cube, we have kilogram meter square per second. We have kilogram meter per second. We have kilogram meter square per cubed seconds. So the one that corresponds to this is actually so C is our correct answer. So had it been this is your examination, your number one question in your exam, how are you going to solve it? It's very simple. It's not difficult. The second question that we have here is what? What is the dimension of viscosity? What is the dimension of viscosity? The formula for viscosity is what? Force over area times velocity gradient. Now this velocity gradient is equal to velocity over change in distance. Velocity over change in distance. That's what velocity gradient. So whenever you have a quantity with gradient, it means the quantity over distance. Velocity gradient, velocity over distance. Temperature gradient, temperature over distance. Let's get down to the problem and tackle it. Let's provide the solution now. Okay, the velocity is what? Lt minus 1, and distance is what? N, right? Good. Remember, this, we cancel this, and you are left with what? T. This is for velocity gradient. So let's go back. What? Lt minus 2 over, then we have our area n squared times our velocity gradient, which is from here we have gotten t minus 1. Using the laws of indices, we have m, and it has indivisible power, which is what? 1. Bringing this one up, it becomes minus 2 because of the division here. So if this one is coming up, it becomes minus 2. Now we have t minus 2. Once this one comes up, it becomes minus 1, and this is equal to m, and 1 minus 2 is minus 1, t minus 2, minus minus is plus 1. Now this is m, and minus 1, then we have t minus 2 plus 1, we have minus 1. This is our answer. We have come to the end of today's class. If you have more questions under dimension analysis, please let's see in the comment section. Hope you gained value, and I'm super excited that you followed up till the end. Alright, subscribe, share with your friends, like and comment.